So how could we possibly get a rotation from a vector3 as a direction? Okay, let's have a look at this. So I have my sphere in world space, and I wanted my cube to rotate. So it looks at that sphere. See? That is a rotation now. So how do we get a direction as a rotation so we can rotate our objects? Let's have a look at that. So we have a look at here. This way we can immediately say to our transform, look at a vector3 position in world space. Okay, world position vector3. So we could just use look at this world space vector3. But quite often you want to get a rotation in relation to another game object. So let's just jump straight into something that is quite very confusing, but there's some parts of here that we can pull out and use for ourselves. So rotations are quaternions. Now, a quaternion isn't angles like you used to, or even angles like you see in the inspector. These are what's known as Euler angles. These are angles between 0 and 360, which we're all familiar with. Now, modifying the rotation component is very fiddly. It could be quite a nightmare. So I'm just going to throw in this quaternion without much explanation, and then if you see how to use it, hopefully reading up and knowledge from that will come from there. So, similarly like look at, in quaternions we have something here called a look rotation. Let's just look at the example. Relative position. Okay, so we're taking a vector3 that is in world space, and we are making it at vector3 in relation to ourselves. So we have the world space vector3, and from that we take away our position. And that should leave the local vector3 as a direction. And then you can quite simply see here, the rotation is simply this command of that calculated local vector3. Now let's try and unconfuse that and put that into script. So we have, this is on the cube, so this is the cube's transform, and we've got the sphere transform. So we want to say, find the rotation between us and the sphere. So, local direction. Actually, I'm creating a new variable here. Just a local variable even. And this will be a vector3. And this will equal our sphere. Now we're using the transform component of the sphere already, so we can immediately access the position variable. So our sphere position minus our transform position. So this should convert our world space sphere coordinate to a local space direction in relation to us. It's getting a bit confusing, I know. Let's just punch in the rest of the quaternion and see it working. So, I don't like using the names that are the same as names in Unity, so I'm just going to abbreviate there. That is our look rotation. It is of type quaternion. And it is a quaternion look rotation. So our quaternion look, now our autocomplete's working. Our we're turning a look rotation, and from that we feed in our Vector3, which is a local space, and it's signifying a direction. So we've created our rotation. Let's just rotate our cube. Transform our rotation is now going to equal our calculated look rotation. Let's see if we can make this happen. Save that out. Let's bring in our axes. We're not using that Vector3 at the moment. So we've calculated rotation based on a look direction. Let's hit play and see if that's working. So there we go. We see the cube has rotated itself to look in that direction, that Vector3 that we've given it. Okay, let's see what happens if we move the cube around. Okay? So even though we're moving the cube, we're calculating where that sphere is in relation to ourselves. Right here. Okay, this is where we're transforming this world position, our Vector3, in world space, and this is how we're calculating it to a local direction in relation to us. So similarly, we should also be able to move the cube around, the sphere around. There we go. So we're working out where this object is in relation to us in local space. So if we're looking on our forward, where is it in relation to us? And then we're calculating a rotation, and then we're assigning that rotation. So there we go. That's turning a Vector3 as a position into a Vector3 as a direction, and then turning that Vector3 into a rotation. Okay, this is just the basics because I'm just introducing these ideas now. You'll see them all come together when we start working on our new script. See you then.